Let's go on a little bit of a digression and talk about alternate number systems. You and I are used to using what we call the decimal or base 10 number system, where we count from 0 up to 9. We've got those 10 symbols that let us count. Once we get out of that range, once we get up to 10, then we reset and we say we've got one set of 10. 1 0 is one set of 10. And then once we get through that, we go to two sets of 10 all the way up to 99 until finally we've got no more things that no more numbers we can represent without adding a new space. That is basically the same structure of the binary number system. So one way we might think about this is with the question of how many numbers could you represent with, say, a set of boxes, or let's just say a set of light bulbs. So let's say you got these light bulbs and they count as filled in. If you put a starburst into the thing, this is a light that's turned on. So how many numbers can we represent? Well, these things have two states, bi for 2, so it can be on or it can be off. Now the question is, how do we count with that, right? This is essentially the question of how do computers deal with numbers, given that computers can only deal with on-off switches, right? They are dealing with a circuit is on or a circuit is off. They're doing essentially the symbolic logic stuff we're talking about, but here's just an application of that. So if we want 0, well, that's easy. We just turn all our lights off. If we want 1, well, we could turn one light on. Now, we could say any number of those lights on could represent 1, in which case our possible numbers are we got 1, we got 2, we got 3, or we got 4. But that's not taking full advantage of what we could do, because this 3 is not necessarily the same as this 3. So here is how binary works, just like with counting from 0 up to 9 and then saying 10 up to 19, then 20, up until 99 goes to 100. Here we've got 0, and then we got 1. Well, now we've run out of symbols, so we could move to, we've got one set of 2. This is 2 in binary. There's 3. Well, now we've run out of symbols. So if we've got one light bulb, we can represent the numbers 0 and 1. If we've got 2, we can represent 0, 1, 2, and 3. To get to 4, we need to add this. So let's count in binary. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and to get to 16, we're going to need a 5th slot. So when we see something like 1001011, what we can do here is we can say, well, this is 1, plus we've got 2, plus we got 0, representing the 4 space. This one represents 8. This is going to be 16, 32, and 64. So 64 plus 8 plus 2 plus 1, that gives us what, 75. That's all that there is to binary. It's just a simpler number system. Now, another one that's pretty common, or well, common, maybe common, but popular, I believe it's dodecimal, but let's just call it base 12, because I don't want to try and rely on my memory here. And this is just counting by dozens. So this is something that we used to do as a species a lot more often. Back in medieval era, we counted by the dozen a lot more often. We'd say, I want a dozen donuts, or I want a gross of something, which is a dozen. So there we need a couple more symbols, but again, we can go from 0 up to 12. And then once we're out of symbols there, then we say we've got one set of 12 plus something else, right, until we get up to finishing that up again, and then we can say we've got 12 sets of 12 sets of 12. And in this order, right, we can keep building up by adding number spaces. Now, why do we care? Well, maybe we don't need to. You don't need to understand binary to do well in this class. You don't need to know binary to do well in life. But what we can get out of this, for one thing, is it's giving us just a little bit more texture to the world we live in. It's hopefully, certainly I found this, hopefully this will make your view of the world a little bit richer. You'll see just a little bit more texture in the universe. Recognizing that we can count with different base numbers also means that we've got this ability to recognize that our number system is ultimately a human invention, and if it's not going to do the trick for us, then we might want to move to something else.